Concurrency in Go is awesome, but there's a bunch of common patterns with weird, tricky nuances that are used all the time. And they're super important to know if you want to be an effective Go dev. So today I'm covering the basic concurrency patterns that you'll see out in the wild. So let's get to it. The first and most fundamental concurrency pattern you'll see in Go is a for select loop, because it's used in a bunch of higher level patterns. You'll see some more complex examples of this when I go over the other patterns, but for now, I want to start with just something pretty basic. So let's say we have two functions. The first is bark, which accepts a send-only string channel, defers the close to that channel, and then every 500 milliseconds, we're going to send a string to the channel. The second function will be meow, and it'll do the exact same thing, but it sends meows, and it'll do, let's say, every 100 milliseconds. And if you need a refresher on the basics of concurrency primitives, one of my previous videos went over that in depth, and I'll leave a link to that in the description. Then in the main function, we'll make a wait group and the two channels. Okay, then I will start up the two functions in two different Go routines and wait on them. All right, this is where the for select loop comes in. So we have two channels that are accepting data from two different sources, and we want one Go routine to handle both of them. So we're going to spin up another Go routine, and then inside that Go routine, we're going to use a for select loop. Inside the select statement, we need to handle a case for the dogs channel and the cats channel. And in both cases, we are just going to print the value. So now we have an infinite loop running over our select statement. And the key point here is that the select statement will pause the Go routine until we receive a value from either one of these channels. So the first one we receive from will run that case. But it's also worth noting that if both cases are ready at the same time, then Go will just choose a pseudo-random one. So you can't rely on ordering. And now if I run this, we should get barks and meows. And we're only getting barks. There we go. All right. So this code works, but it runs infinitely because we never exit any of the Go routines. We just have infinite for loops in all of them. The next pattern is used to address that issue, and it's called done channels. It used to be super common, but it's largely being replaced by the context package in the standard library, but it's definitely still worth knowing about. So first, we need an empty channel. This is the done channel, and you'll never actually send anything to the done channel. So we use an unnamed empty struct as the type. And instances of that type are 0 bytes. So it's convention to use that when you're not using the channel for the actual sending and receiving functionality. So now instead of sending values directly to the channel, we can send a one-time signal by closing the channel. So I will register a function to execute after 3 seconds. And in the function, we're going to close the done channel. Then we need to listen for when the channel actually closes. So we'll add another case to the for select loop. Now when the done channel is closed, it will broadcast an empty 0 value to anywhere that is receiving from the channel. So then this case will be triggered and will return out of the Go routine. And then I should update the other Go routines so we don't hit deadlock, and the functions. So each now accepts a done channel. And then we need the for select in each of these, where the first case looks at the done channel and returns, and the second case sends to our channel. Same thing here. Again, sleeping 100 milliseconds, and we're sending meow. Okay, so now when we run this, the dogs and cats should be making noise for 3 seconds, and then the done channel will close, which will signal all of the go routines to exit. So we'll run it. Nice. Now, like I said earlier, manually doing done channels has been replaced by the context package, but internally it still follows the exact same pattern. So let's update this example to use context instead. So instead of the done channel, we want a context that will expire after 3 seconds. Cool. Defer calling cancel. And now we don't need this callback anymore. Then instead of using the done channel in the case, we're going to use the context.done function. And this just returns a done channel. So it's literally the exact same pattern, just codified into the API now. So we need to pass the context instead. Update that and use context.done here as well. Now, when we execute this, we should get the exact same results as before. So we'll run it, goes for 3 seconds and cancels. Perfect. So even though context has replaced the manual done channels, the done channel pattern is still useful to know because you can use it as a general notification channel. It doesn't have to be for exiting go routines. It can be for literally any one-time signal. So for example, if you have a go routine doing some initial setup when your server starts, you can send a signal over a ready channel to signal to the rest of the app that the startup has been completed. Or if you have a job that many go routines are waiting on, but no actual data needs to get sent over a channel, you can just use a done channel or a notification channel. There's tons of examples, but the premise is always the same. You're just sending a one-time signal to many go routines. So this code all works, but in practice, there is another issue with it. If one of these channels closes before the other, let's say the dogs channel closes before the cats channel. Intuitively, you would expect that the dogs channel case would just stop being called. But instead, what you'll get is the dogs channel case being continuously triggered over and over again. Because once a channel is closed, any statement waiting on a receive from that channel will instantly receive a 0 value from the channel. So to demonstrate this, I will use 2 different contexts. A long context that cancels after 3 seconds, and a short context that will cancel after 1 second. And we'll pass the short context into bark and the long context into meow. And then we'll use the long one down here. So now, after 1 second, the context sent to the bark function will be canceled, which will trigger our case here, which will exit the go routine and cause the channel to close. So we'll end up with a closed dog channel, but an open cats channel. And I'll add a string here just to make this visible. So now when we run it, we get the normal output for a second, then bunch of dogs. So after the dogs channel was closed, this case just triggers over and over again, and we get a bunch of empty strings, which is the 0 value for the channel type. Luckily, the fix for this is pretty straightforward. When we receive from a channel, before we do anything, we want to check if it's closed or not. So this check stops the empty data from being printed, but it doesn't solve the problem completely because this case still triggers. It's just not doing anything. So it's still looping over and over and over again. Now the real fix is to set the channel to nil. So we'll flip this. If it's not okay, then we want the dogs channel to be nil. So now when the dogs channel closes, we should just get the results from the cats channel because a nil channel doesn't send anything. And we also need to break here to exit the select statement. So now when I run this, we get the normal output and then we just get cats. Cool. So if you're listening to 2 channels at the same time, setting the channel to nil once it's closed is a good pattern to prevent this bug. And if you want more videos explaining non-intuitive issues like this, then subscribe and stay tuned for more. Okay, so the next pattern used to be used to create a done channel that would close when any number of other done channels closed. Officially, this was called an OR channel, but the naming makes a lot less sense now that we have the context package. So I like to call it a merged context cancellation. If you want to see the original implementation, there's a lot of blog posts on it, and there's an example of it in the Concurrency and Go book. So let's say we have 3 contexts, and they all come from outside of our control. And the external context function is just for demonstration to make it clear that it's coming from somewhere else, but it just returns a new context here. So usually you would use a parent-child context relationship to cancel a bunch of contexts at once. But Go doesn't have any way to add a parent to an existing context. So if we want a single context that gets canceled when any of these get canceled, we need to build a new helper function for that. So I'll call it merge cancel, and it will accept a parent context and then a variadic slice of other contexts. And then we'll return a context and a cancel function. So the idea here is we're going to return a context that gets canceled anytime any of these contexts that you pass in are canceled. And then we have the cancel function just so you can cancel it manually as well. So first we'll create the merge context that we're going to return. We'll also get a cancel function, and we're going to use context.with cancel cause because it'll let us tell which of the contexts that we passed in was canceled to make the merged context cancel. Then we'll loop over the context passed in. And for each one, we're going to register a function that is executed when the context is canceled. So you can do that using context.afterfunc. Pass in the context and the callback. Inside of this, we're going to call our cancel function up here and pass in the cause as the context that is making us cancel the merged context. But we still have this stop value that's returned by afterfunc. So that's a separate function that can be called to remove this hook from the context you attached it. So once we cancel our merged context, we no longer need any of these hooks to try to cancel it again. So at that point, we should call stop for all of the contexts. So I'll make a slice to hold all of the stop functions, and it'll be the length of our context slice. And then in each loop iteration, I will add the stop function to stops. And then, like I said, after this merge context is canceled, we need to clean up all the hooks that we don't need anymore. So I'll use the same afterfunc function to register a hook for the merge context to call when it is canceled. And in here, we're going to iterate over the stop functions and just call each one. And last, we just need to return the merged context and a cancellation function. And I just wrap the cancellation function that we have and pass nil as the reason. So that's the helper function. Now to use it, we need a parent context. And then we'll get our merged context and a cancel function using merge cancel. And we'll pass in the parent and then all 3 of our initial contexts that came from an external source. I'll also add a wait group so we can actually test this. And let's do wait group.go func for select. And we're going to wait on the merged context.done channel. And if that case triggers, then we'll return. Otherwise, we're just going to print running. And now we're going to register a new function to call after, let's say, 2 seconds. And all it's going to do is cancel one of these. And theoretically, it doesn't matter which one. So if we call cancel 2, and I'll replace these. And now when we run this, it should run for 2 seconds. Then the context 2 will be canceled, which will cancel our merged context, which will exit our go routine and let our main go routine proceed. So when I run it, we get running and it stops. Cool. And if we have a different one and run it again, we should get the exact same thing. Awesome. So just to make the pattern with the merge cancel function absolutely clear, the result of all this is we have the 3 contexts that are outside of our control, and then our merged cancel context that is conceptually like a child of all 3 of these. Because with a regular context, if you cancel it, all of its children get canceled. So in this case, if we cancel any of these, then the merged one gets canceled. And again, if all the context code is in your control, then you 100% shouldn't do this. You should just use a parent-child context relationship. So this pattern is more niche, but it's still useful to know. Okay, the last thing I want to cover in this video is the error group package. It's not part of the Go standard library, but it's still maintained by the Go team, and it's super useful. It basically gives you some extra concurrency primitives that let you run multiple Go routines together and then cancel a context if any of those Go routines return an error. And then you can also wait for the Go routines to complete with the error group. So it's basically a wait group with error handling and context cancellation kind of grafted on top of it. And first you'll need to install it. So do go git, there it is, golang.org/x/sync/error group. Then you can create an error group and the context associated with that group using error group dot with context, and you pass in the parent context. Next, we'll start a couple Go routines, and just like with wait group, you can call group.go and pass in the function. The only difference is it can return an error. So here we'll just print some stuff, sleep for a bit, and then return an error. Okay, so now we need another Go routine. And for this one, we're going to do a for select loop where we're looking at the group's context. And if the context is canceled, I will print canceled and return nil to exit the Go routine. And then we'll have a default case that is just running. Cool. And then you can wait on those the same exact way you would do it with a wait group. But unlike with a regular wait group, this wait function may return an error that gets returned from any of the Go routines. So we can do if error equals group.wait, and if it's not equal to nil, then we're going to log the error. So this is the best feature of this package by far because it lets you group a bunch of Go routines that either succeed or fail all together, and then lets you handle that error. So now if I run this, the context should get canceled after the first Go routine returns an error. So the first Go routine sleeps for a second, returns a new error, which will cancel the context automatically. So we'll exit out of this, and then we'll stop waiting and get our error to log. The package also has some features to let you limit the number of Go routines running at one time, and I'll leave a link to the docs in the description if you're interested in that. And that is all I got for today. Next video, I'll be going in depth on pipeline patterns in Go, So make sure you subscribe and stay tuned for that because they are much more challenging than these basic patterns. As always, keep breathing, keep building, and I'll see you next time. Peace out.